Alright, because I mentioned a minute ago, same set of boundaries we just had, but my difference is I have a revolving around the line y equals -3 instead of around the x-axis. So when we consider this boundary, the biggest difference that's happening is this particular boundary is still existing in these same locations. So this is 4, there's my shape, but unlike last time, this time my axis of revolution is down here, somewhere. Probably should be a little lower. And this is the equation y equals -3. Now, because that axis has changed, I have this top edge that has to go from here all the way down to the axis of rotation to determine a radius of that item all the way down. So a question that comes up is, so both have a ring like this. How much metal is within that ring? It's not just going to be the thickness of the ring band itself that's going to tell me the amount of metal in this. It also has to do with, well, how far away is the center of that from the outside edge as a radius of a circle. Is that true? And then, of course, it relates to the thickness of it. What?
I said I have no idea what you're saying.
Let me ask a different question. Pause on this idea for a second. Let's ask a different question. Nope, don't do that just yet. There's the center point.
Yeah.
It's almost meal time. Let's suppose you might eat a donut at your meal. A bagel? Would you have a bagel?
Yeah.
Okay, you can have a bagel.
The bagel be bigger.
The bagel will be bigger. Alright. Guys, imagine whatever you want to that's a circular food item. That'll be good enough for us. We hope. But I have to know that if this radius is 1 inch, and this radius is 3 inches, no, it's not drawn to scale. So, if you're going to have to cover the area of that thing with whatever spread you want, how much area are you covering? How would we figure it out? Yes.
Can't you just find the area of the big circle and subtract the area of the little circle?
That is precisely correct. And that is exactly what we're trying to do with our volume question.
Why are we doing it the hard way?
Well, I'm trying to give you the theory behind it.
So we don't need to write this down?
You don't have to write it. This is trying to give you an example of how things are being thought about here. When I revolve out a y, that's not on my shape. There's a hole in the middle. And to get volume, it's basically going to be, I've got the larger item of the ring and the smaller item of the ring going to subtract out. So this larger item is still capital R of x. And this time I want to know, how do I find the value of the capital R of x? What's the equation of the top curve? What's the equation of the bottom side of this thing? So we still have top curve minus bottom curve being our concept, but now it's a number that's not 0. So this is the square root of x, then plus 3, not under the root. But this time we also have a piece of it that we have to get rid of. This part down here, it's the space that's creating the hole in the object. And we're going to call this little r of x. And I need to know what's the top edge of the little r of x and what's the bottom edge of the little r of x. So 0 minus negative 3. Or just 3. So let's put the pieces together. Volume is going to be pi times the antiderivative from a start to a finish. But this time we want to talk about this big, capital R, the big piece, creating a solid feature. So R of x squared. And then we're going to subtract away or hollow out the smaller piece of little r of x. Again, because it's circular, quantity squared, differential dx. So this is what we're putting together.
But you don't want that
The pi is in the very front. So it's going to be multiplied to both of them. Guys, if you want to see a visual of this, go watch somebody turn a bowl on a lathe. A bowl. When you would eat cereal out of a bowl. Watch them turn that on a lathe, and you'll see if they have a solid chunk of wood, they surface the outside with circles, and then they hollow out the inside. A lathe, the machine that spins half the wood around the circle. That's the thing. They make videos on YouTube. Waste 20 minutes. Guys, the concept that's happening here of an outside edge and then an inside edge, you will see very much illustrated in the concept of somebody doing wood turning. You can watch them take a solid chunk of wood, they do some stuff on the outside to make the outside curvature, and then they clear out the inside, or they hollow out the inside. And that's the same idea of what's happening here, a top curve minus bottom curve concept. It's the same idea. They're looking for the radii and that kind of stuff happening. We have all this. Let's put the pieces together. So volume equals pi. We're going from what x number to what x number on our shape up here? Capital R of x is squared minus little r of x is squared. And then the whole thing times dx. And dx is the representative thickness that we want to make extremely thin in each of these pieces. Questions so far? Well, that means I'm trying to teach you something. Volume equals pi times the antiderivative from 0 to 4 of the square root of x plus 3, which is our capital R of x squared, minus 3, which is our little r of x squared, differential dx. There's our equation, and we just work it out. Questions about this? So when I multiply out square root of x plus 3 squared, x plus 6 square root of x plus 9, and then you multiply out 3 squared is minus 9, differential dx. Does that look correct? So the math is going okay. So the volume is pi times the antiderivative from 0 to 4 of x plus 6x to the 1/2 dx. Now we're ready to take the antiderivative. So far we hadn't really done any calculus. Now we're ready to actually do a calculus step. So the reason we're in the class. Let's do that. So volume is pi times 1/2 x squared plus 4 x to the 3/2. 0 to 4. Is that correct? We'll just say yes because I wrote it. We agree? The nice thing is I look ahead. If I put 0 into both of these, I'm not going to have any value out of the 0. It doesn't give me any other number. So I'm really going to concern myself with putting the 4 into each of these parts of the problem. and get 8 plus 4 times, what is that, 8? And so it looks like 40 pi units cubed.